Okay, welcome back to the Python tutorial seminar series. Today, Deepak Cherian will be covering an intermediate lesson on Xarray titled Thinking with Xarray. You will be best served by this tutorial today if you have some experience with Xarray already. So please look at our past Xarray tutorials for guidance if you need some. Deepak Cherian is a project scientist and physical oceanographer in CGD here at NCAR. He helps maintain Xarray and XGCM and contributes to other projects in the Pangeo ecosystem. So that speaks to some of his authority to help teach you Xarray. But before we begin, I need to review our code of conduct. By joining this Zoom call and participating in this tutorial seminar series, you've agreed to adopt these values and engage in respectful communication only. Any inappropriate remarks will have you removed from the call by one of our co-hosts. In this tutorial, there'll be several natural stopping points throughout the tutorial. So after each new Xarray tip, trick, or function that Deepak introduces, there'll be time to answer some of your questions relevant to that function. So ask your questions in the chat throughout the whole time, and the co-hosts will try to answer some, and then you'll get some more attention and examples and whatnot interspersed throughout the session. And as always, the recording and one-on-one assistance will be available afterwards. And here are some learning resources that I'd like to direct you to. Again, as always, Stack Overflow. The Xarray documentation is a great place to answer a lot of your Xarray questions, and today's content, which is on GitHub in the Project Pythia tutorials organization. And I will link you to that in a second, and hopefully you have it from your emails and the blog post. And with that, I will hand it off to Deepak.
Great. Thank you, Julia, for that very nice introduction. And thank you all for coming. Okay. And so I've just shared my screen. Does everything look good? Does the font size nice?
It looks good to me.
Great. Okay, so welcome everyone. I thought I'd do a kind of quick lesson on things I like about Xarray. And this particular topic is called high-level computational patterns. We'll see what that means soon. You probably already know a bunch of it. And the motivation, I've copied here a little paragraph from this, the documentation for a package called tools. And as I really like this paragraph because it points out that there are a small number of patterns that are common to many data analysis tasks. And so once you learn a core set and you learn to think in terms of those patterns, you quickly become very effective. And as they say, there are a few advantages, which is that you identify new patterns. You also tend to identify when you've done a similar piece of analysis in the past, and you can kind of try and reuse your code. And you can depend on well-tested and benchmarked implementations. And this is mostly true for Xarray too, though certainly things can still be improved. So as Julia mentioned, I'm going to assume that you've used Xarray and that you've used at least some of these high-level functions, things like rolling, coarsen, group by, resample. And that's what this lesson is going to cover. And to me, Xarray has at least two big advantages. The first one is that it lets you use the metadata of your data set to help you write more readable analysis code. And so instead of calling things like take the mean along axis equals 0, you could use the dimension name. So you can say take the mean along latitude, and this is a much more readable version of getting to the same result. The second piece of metadata that it has are coordinate labels. And I tend to think of these as axis labels if we were to plot them. So we would say latitude is 45 knots, 45.5 knots, so on and so forth. And the nice thing with Xarray is that you can actually use that. So instead of asking for the 10th element of data, you can tell it to select the values at latitude equals 45 knots. And In a similar manner, Xarray also provides, what I've been calling high-level computational patterns that leverage this metadata to make your code more easier. And again, as I mentioned earlier, you tend to identify patterns in your analysis, and you can kind of leverage that knowledge to work faster and think more about what the science goals of what you're doing, as opposed to the low-level details of what you want to do. So you're going to start by just running this first cell. I'm assuming that you're all going to follow with me as I go through this notebook, and feel free to ask questions. I think it'll work better if we just answer questions as they come up. So what I've done here is just a couple of imports. I set a couple of options so that things look nice in this notebook. It doesn't matter. I've loaded a little data set. It's a sample tutorial data set that comes with Xarray itself. I'm pretty sure this data set was created by Joe Heyman here at NCAR. So I think it's like a small bit of model output. And so it shows the air temperature over North America. So you can see kind of lat and long ranges. So that's DA monthly. I've created a new data set that's the monthly mean of that. And then data is going to be just a single data array for the first time step. So this is the monthly mean temperature for January 2013. Yeah. Actually, no, I'm sorry. This is the 6-hourly mean temperature because I pulled it out of TA, but it kind of doesn't matter. There are a bunch of data sets here that we will work through slowly. And so the first concept, or the kind of underlying concept, I think, that's all over Xarray, is this idea of thinking in index space versus the thinking in label space. And by this, I mean, if you wanted the values at latitude equals 40, for example, and you're thinking to yourself, I need the values at latitude 40 knots. I refer to that as you're thinking in label space. So you think of actual dimensional values that have physical meaning, as opposed to something like the 10th element along the latitude axis, or axis equals 0, or something like that. And so if you're thinking, axis equals 0, or the 10th element, that's index space. And if you're thinking in terms of physical quantities like the latitude 40 knot, that's label space. And so, just a quick demo there. Here's our little data array. It's 2D, so lat long. Usually you work, if you're coming from outside Xarray, and I came from MATLAB, and in MATLAB you would usually pick the 10th element like this. You don't really know what it is. You kind of have to look through the metadata yourself to figure out what it actually means in physical space. Here it turns out it means latitude equals 50. Xarray provides this ice cell thing. So I read that as select the index 10 along dimension latitude, right? Which is exactly the same thing as the thing above. Or we could ask it to just give us latitude equals 50 using cell, not ice cell, but cell. So this is now in label space, and it's not much better. And so that concept really maps onto these high-level patterns. So first we'll talk about rolling and coarsening. Both of these work in index space. And then next we'll think about label space, where you'll find group by, basically, and then two specializations of group by, which is group by bins and resampling. And so the reason the rolling and coarsening are, I think of those as index space operators, is that you're thinking about windows of fixed width into your data. So we'll see what that means. So here again, I'm going to start with this data array, right? So it's just 2D, and I plot it. And what we're going to do is calculate like a running mean. And the way you do a running mean with Xarray is to use the rolling object. It has certain properties, it makes certain choices. One of that, it always returns an object of the same shape as the input. And because of this choice, it has to do a little bit of padding to make sure there's enough values at the beginning and the end to make this happen. And one slightly less known feature is that you can actually do rolling across multiple dimensions at the same time. And so the first demo is really just to show how rolling works. Is I'm going to take that data, I'm going to call it dot rolling, lat equals 5, long equals 5, center equals true. And so usually if you just call rolling, you'll get what's called a rolling object. And this object has a bunch of methods. Here I'm just going to call mean, but it's got things like sum, variance, standard deviation, all the usual stuff. And you calculate the mean of that, you end up getting this result, and we'll visualize that by plotting it. You'll see that you get a much smoother version of the input data set, right? So it looks like the 5x5 running mean, which is great. I pass center equals true, which means it pads with nans at the left, right, and the top and bottom of this data set. So that's why you have a bunch of white squares around it. So that's pretty good, right? And as long as you only have to do things like the mean and sum or something that's provided by the rolling object, you're all fine. But a lot of times we don't want to, right? Maybe we have something custom, a little custom function that you want to apply. And so to do that, the rolling object actually provides you with a reduce method. And the reduce method, you'll find it throughout Xarray, like data arrays have them, data sets have them. And this tip is a pretty good way to remember what reduce is. It says that the reduce method, you use that when you need to provide a function that can receive and return plain arrays. I'll get to the question in the chat 1 second. And there is a parallel map method, which is very similar. So it's a custom function, except this function should accept Xarray objects and return Xarray objects. And so this distinction between reduce and map applies to many Xarray things. Here we're going to see it for rolling and coarsen and group by. And so to summarize, this little piece of the lecture is going to look at the function numpy.mean, but you could pick any other custom reduction function that you have. And we're going to use the reduce method to apply it within these 5x5 rolling windows. So the question in the chat is, what is the default padding method for rolling? The default is to just add nans, which is what's happened here. So if I just, you'll actually see this a little later on too, but you'll see that there are a bunch of nans that come in the output. And so that's it. It pads with nans. This cannot be customized right at the moment, but I have some plans for trying to fix that in the future. But right now you'll only get nans. Okay, and so back to what we were doing. So there's a little exercise cell here. So I'm going to pause for about 30 seconds. The question is to calculate the rolling mean and 5-point bins, which is basically similar to what we have here, but instead of calling .mean, use the .reduce method and apply the function numpy.mean. Okay, I'm going to assume that some of you are on the way. There's a little cell below that has the answer. And you'll see that the plots kind of look the same. Well, if I scroll a little further up. Oh, I think I lost it. Aha, it was here. You see the plot looks the same, but instead of calling a built-in method .mean, what you've given it here is you've called the reduce method .reduce, but given it a function, the mean. And so this is exactly equivalent, but you could think of plugging in a custom function. Something like NumPy has a peak-to-peak method, so that just takes the difference of the maximum to minimum, right? So maximum minus minimum along an axis. And so just for demo purposes, so that we can look at something different, here's the kind of dynamic range of all the data in those 5x5 windows. And so you can do this with any function that you write to. Again, the real expectation here is that if you're giving a function to reduce, it expects pure array, something like a NumPy array, and will return back a pure NumPy array, not an Xarray thing. I think that would raise an error. Okay, so that's kind of tip one, is that Xarray objects usually have things like a reduce method and a map method. So you can kind of apply your custom reduction functions on them. Sometimes you want to do something more complicated that's not a reduction. And by reduction, I mean it's a function that takes a bunch of values and maybe returns a much smaller number of values, something like a mean or a sum. And so one common thing that I've sometimes had to do is something like a short time Fourier transform or spectrogram, or you're doing the rolling window, but you want to multiply it by like a weighting function or a window function, like a Han window or something. And that doesn't really fit in the reduce. I mean, it could fit in the reduce thing, but I'm going to show you a slightly different way of doing it. good question. So Steve Yeager asked in the chat, will reduce work on task arrays? I think the answer is yes, but your function has to be smart enough to be lazy about it. So it expects bare arrays, so something like a numpy array or a task array or sparse or something like that. So it should work. Okay, so to demonstrate this idea of looking at a rolling window of your data set, I'm going to start with just this very simple array. So all it's got is values from 0 to 9. I'm thinking of this as a time series. And again, we're going to look at the 5-point rolling window. But this time I'm highlighting the construct method. And so what that does is kind of interesting. So you see you've given it simple was a 1D data array in time. And now the output after I did this rolling.construct and I gave it a new dimension name window is a 2D array. So time is still the same length, but now it has this new dimension window that is of size 5, which is the size of that the window size that you provided to the rolling object. And so what it's done is, as you can see, is it's sliding through the data array. The first step, what it does is pads a couple of nans at the beginning and the end, and then it constructs 5-point views, a block of 5-point values, and then slides that along the array, right? So you can see you go nan, 0, 1, 2, a single nan, 1, 2, 3, and so on till you get to the end where you have a couple of nans there. And so this is now useful because you could do things like calculating the Fourier transform along the window dimension. You could multiply, you could create a little window like the Hahn window of 5 points, and you could multiply that and then do other more complicated analyses. And so here's just a very simple exercise. It redoes what we did earlier. So use this construct approach to construct the 5-point running mean in time. And so I'll wait again here for 20, 30 seconds. And if you have questions, please feel free to ask. And so here's the answer. And so, the first bits are the same as above. We construct this little 2D array. And then now remember that these 5 points are your windowed view, right? And so all you have to do is just take mean along the windowed dimension. As you do that, and you'll end up getting the 5-point running mean. And so, it's a very simple example. And what you get out of construct is another Xarray thing. And so you can kind of do just anything you want with it. It's really just a convenient way of reshaping an array. So you have this convenient view as a sliding window. And so a little summary is that construct is kind of clever. There's some details. I don't, if you're interested, you can look this up some more, but it constructs a view of the original array. So it tries to be pretty memory efficient. What it will do is, in this case, it will take these 10 values, it'll copy it to add a couple of nans at the edge, so it does the padding. And then after that, it's clever. So when you construct, instead of the memory usage of 50 elements here, you really just have 15 elements, for example. And so that's something that's cool and something you want to be kind of careful about when you're doing these big sliding windows. You can blow up memory really quickly. And so it's kind of nice that construct does that for you. It actually does something sensible for task arrays. So kind of coming back to Steve's question, but we could do a whole lecture of the same thing, but with Dask. If you're thinking of Dask with rolling, the one thing to keep in mind is communication costs. So if you looked at just our 10-element time series and assume the chunk size was 1, if you wanted to do the 5-point rolling window, it means you have to do a lot of communication, right? To send. So if you're sitting over here at element 3, you need to know 2 elements forward and 2 elements back. So there's a lot of data that has to fly around. So in general, it works better if your chunk sizes are bigger along the rolling dimension. But it does something sensible, and it's not going to totally fall flat unless you're doing some really big rolling and really tiny chunk sizes. It also works with rolling along multiple dimensions. So I've just put that in here. It's kind of hard to interpret, but you'll see that I said 5-point rolling window, lat and lon, and I say construct, and you have to give it a new dimension name for each of those input dimensions. So the input was a 2D data array. The output is now 4 dimensions, and you can see those rolling dimensions have a window of 5. And so now you can call mean on those 2 dimensions or apply whatever custom analysis you want. It should work. Okay, and so that kind of concludes the rolling bit. Do people have any questions? If not, I'll wait for 10 seconds, and if there are no questions, I'll move on to the next bit, which talks about coursing. Okay, moving on. So the next kind of high-level pattern is coarsening. So we thought about rolling, which is a sliding window, right? So you take 5 points and you keep sliding them side by side. Coursing is very similar, except the windows never overlap. So these are non-overlapping windows, or blocks, if you want to call them that. And so the idea, you could think of it something like a very simple coarse graining or something like that. And the syntax is very similar to rolling. And you'll look at all the same methods really just again. So this is that same idea, like once you kind of learn about a little pattern, the fact that things have a reduce method or they have a construct method, you'll tend to find them in many places. And they can make your life easier that way. And so here's a little data set. Let's just look at the sizes. So you see there's 25 in lat and 53 in lon. And so here I'm going to ask for 5x5 blocks that are non-overlapping. And what happens is 53 is not divisible by 5, which means you have to do something about those last extra 3 values at the end. There are a bunch of options. You can pad a value if you want. Here I'm going to say trim, which means just discard any excess, just because it's easy. I figured out a cell, so I wanted to do this over here. So if you just call .coarsen and you give it the window widths are 5, and I say trim the boundary, you'll get back a little coarsen object, and this thing has a bunch of methods. So I could call mean in those 5x5 blocks. I could call standard deviation. There's a whole bunch of standard stuff, right? And so here I'm visualizing the mean, and you can see compared to here, you've kind of coarsened everything with the mean operator in 5x5 blocks. And note that this 5 here means 5 points. So again, we're working in index space. It doesn't really care about what the dimensional values are. It's just going to go every 5 points. Okay, and so coarsen is very similar to rolling, which means it also provides a reduce method. And so the little exercise here is to replicate what's happening here, but with use rolling coarsen.reduce, and you apply numpy.mean. And so while you do that, I will look at the chat. So Seth asks, is there a way to work with label space with coarsen? Yeah, so that's called group by, and we'll get to that next. So I guess I should say that the group by, you can only group by one variable. So it's not a, you couldn't group by lat and longitude at the same time right now. Hopefully I'll have this fixed in like a month or something. But the generalization of generalization of coarsen to label space is group by. Okay, so here's the little answer. I'm hoping you guys are all following on. And again, feel free to ask questions in the chat if you have trouble writing up these solutions. And so I called data the Coarsen, I give it 5-point windows in lat and lon, told it to trim the boundary, and I passed numpy.mean to the reduction, to the reduce method, and I plotted that out, right? And so that's the answer. Again, you can do whatever you want. Here's peak to peak amplitude in those 5x5 windows. All works. Again, now moving on to the next one, which is construct. So just like rolling, Coarsening has a construct, except this one's a little interesting to think about. We added this very recently, and so I don't think it's as popular as it should be. And it's, if you've thought about reshaping a particular dimension of your array, so you take a dimension and you want to break it up into a bunch of pieces and stack those up together, that's where you would use Coarsening.construct. And so I'll demonstrate that now for kind of a common problem. But in your mind, if you're thinking I have to reshape a function, like cut up a dimension into pieces, you should be thinking Coarsening.construct. So to demonstrate that, I'm going to create this very simple data array. It's 1D in time, and it's meant to represent a monthly time series. To illustrate, just for illustration purposes here, you can think of these as the month number. So 1 is January, 2 is February, and 12 is December, and so on. And there's 2 years of data right here. And so a common task is we have this long time series, but we want to reshape this thing into a 2D array that is shaped, has years along one dimension and months along the other dimension, right? And so the syntax is here. It usually takes me some experimentation to figure out how to write it. And so I find it really useful to come back to this example. So that's, don't worry if it's a little confusing, but I think once you look at it, you'll get it. So here what I've said is, I know there are 12 months in a year, so my Coarsen window size is about 12. And then I called our construct and I tell it, take the time dimension, split it into 2. The first one's the year and the second one's the month. And here's the output. So you see you have it going from 1 through 12 along the dimension month, which makes sense. And we had 2 years of data, so we ended up with size 2 along the year dimension. And so we went from a 1D array to a 2D array. And a few things to note is the initial data set had this time coordinate. That time coordinate also got reshaped, so you can do useful things with it. And the other thing to note is year and month have no data associated with them. They're just sorry, they just have the size. There are no labels. You'll have to do that manually. Also, because I couldn't figure out any good way of doing this automatically. So if someone has ideas, please let me know. But yeah, so there you go. What if your data didn't start with month 1? So I'm assuming then you don't have an evenly divisible thing, right? Yeah, so it wouldn't work so well. So that's where you want to think of maybe like a group by, right? This is like the key problem with like being in index space is you're assuming that things are repeating, or you can go with fixed sizes, and your question really says that there's no fixed size. Can you pad? Yes, you can, but you'll just have to do it. You would just have to. You know what? Let's try and find out. I have to think about this. So we say months. Just, oh no, on. Okay, so now we're starting at 2 and going through 12 and then again through 12s. This, let me just check something. Right, so now it gives me an error saying that I need to provide a boundary condition. I don't use Coarsening too often. Aha, so it did do something. Let's try and do, I suspect though that might pad at the end. Yeah, see, so that's what's happened. So this is interesting. So some control over the padding would be useful, right? So it automatically stuck a nan at the end, so that's not very useful. So we'll go back to my initial solution, which is that there is a pad method. And I think we can say I want a pad on the left-hand side with one element. So in this case, you can see that it's added. Oops, I forgot to cut out the first value. All right, so here's what I did. This is a 23 element array, so it doesn't work well, kind of what Kevin asked about. You have a forecast data set, source and element. Right. But then what are you trying to do? This is a question to Damien, I guess. So what are you trying to do after that? And in the meantime, so here's the pad method, which is also pretty useful. I've asked it to stick, and by default, the fill value is man. I think I could do -1, for example. Oh no. Something has gone wrong here. There's a bug. But let's just assume we wanted a nan, and that was fine. So now you can pad to an even thing. Now you can coarsen n equals 12 to do that reshaping operation that we wanted to do. So that's, assuming that you wanted a whole month, months January through December for a particular year as a row, that's how you would do that. Yeah. Okay. So Coarsening has a bunch of built-in padding, which I guess is not as configurable, but there's always this external pad method that you can create the data array that you want and then just go through Coarsening. We'll do it. And so, lost my little cell. That was up there. I have messed this up. I had a little exercise here that you could try, which is start with this data set that's monthly. So this is the monthly mean of that air temperature data set. And so what we want to do is reshape that time dimension to year by month, just like above, and then visualize the seasonal cycle for 2 years at 250 east. And that's just adding. I made up some work, right, to do. And so I'll wait again for 20 seconds. And again, if you have questions, please feel free to ask in the chat. If you think I should go slower, please mention that too. I think this is a bug. The padding isn't working right. Anyway. And so hopefully you've made good progress through this little exercise. So I started with the monthly data set and I called coarsen time equals 12. So this is exactly the example I demonstrated. I picked this approach to assigning a nice coordinate value to the year, but I was going to try. So here's, oh, whoops, I didn't run it. So here's year and month. And so you can see that the time dimension got reshaped to year and month. You started with the 3D array, now you're up to a 4D array. And so you have it nicely cut up by year. And here's my little thing. So I just took that year and month data set. I selected 250 east. And then I plotted little contours and I put month on the x-axis, latitude on the y-axis, and in 2 columns, I provided the year. So now you can see the seasonal cycle at the same latitude over 2 different years. And so it's a kind of nice way to use coarsening. So that's basically our the ending of the index space bit, which is there are two high-level patterns, rolling for sliding windows and coarsen for non-overlapping windows. And both these provide the usual reductions, so things like mean, standard deviation, et cetera, et cetera. But they also provide reduce so that you could apply a custom function. And they also provide construct, so you can use it for basically reshaping your arrays and doing more complicated things after that. So Xarray knows what the year should be a coordinate because it's pulling from time a coordinate. Okay, so Adriana has a question. I might need some help understanding. So Xarray knows that year should be a coordinate because it's pulling from time a coordinate. So the answer is no. So let's go back to the very simple example, which is here. So I started with this very simple time series and I said, take time and then break it into two dimensions. One is year and one is month. And so I could give it A and B and it will still work, but it won't be very meaningful to us. Oops. Oh, what did I do? Ah. Does that answer your question, Adriana, or is it something different? Did I misinterpret? Did that answer the year column? I see. I guess I may have skipped about for that. Okay, so I'm going to break up this cell. So we can just go step by step. So first I start off by making this year and months. And at this point, you'll notice that there are no coordinate values for year and month. So Xarray doesn't really know anything. It just knows that there are two dimensions, size 2 and size 12, and they're called year and month. And then here, I've done this manually. I called unique, but you could just do, by looking at these values, you see there's 2013, there's 2014. And so you can assign that. And when you do that, you'll see you've created this new little variable that has 2013 and 2014. So now I manually specified meaningful values for year. Coarsening.construct does not do that because it's kind of hard to choose. Yeah, I basically concluded that you couldn't do it automatically. You kind of had to do something manually. Why is that a coordinate instead of data? So it's a coordinate because you basically under the hood done a reshaping. And so you started, let's start with just monthly. So monthly starts as 3 dimensions, right? So time, latitude, and longitude. And then I did my thing, course, under construct. And what it's saying is take the time dimension and break it into 2. So now you've gone from 3 dimensions to 4 dimensions. And when you do that, you have to give it a name for those new dimensions, right? So time, I'm saying break it up into one that's called year and one that's called month. And so it's a dimension name. And now that I've assigned values to it, these labels get associated with that dimension. So now you have a coordinate value or a tick label along the axis. So hopefully that was clear. And I guess a related question from Seth is, could the labels for the month coordinate be strings? So the answer is yes. It's just kind of painful, I guess. So let's try and do that. I'm gonna make a lot of typos now. So if I did that, so now I've assigned these strings and you can see them there. I think, so if I did this now, I think it might actually, oh, it did work and it put strings on the x-axis, so that's kind of nice. So not so bad. Okay, and so I guess the high level question in that chat discussion is basically, it comes down to this point where, once you just call coarsening.construct, you get these 2 new dimensions, but they don't have any information associated with them. So like the metadata is still in your head. The way to fix that is to do some manual assignments like I did here, where you assign names to the months, assign the actual years, and you have to do this manually. And once you do that, you can make this kind of nicely annotated block that has month names and the actual years on top. Cool. So hopefully that was useful. And so the summary is we've been thinking in index space, which means you have fixed size windows, and rolling is a fixed size window that slides one element at a time. And coarsening non-overlapping windows, which means you have to make a choice about what you want to do at the rightmost boundary. And both of these, you have all the usual reductions like mean and stuff, but they also provide reduce and construct, so you can do some custom operation that you want. And so this is where you can take your existing analysis code and try to fit it into Xarray's way of doing things through rolling and coarsening, and you get to like leverage those patterns a bunch. Okay, and so now we're going to switch to what I like to think of as label space, which means we are thinking about in physical space. And kind of related to Sat's earlier question, I think of group by as kind of a generalization of coarsening, right? So coarsening, you have fixed size windows, but sometimes the windows you want are not regular. This is very common in climatologies, right? So if you're going from daily to monthly, not all months don't have the same number of days. And so that's all. So it's really hard to fit that into a coarsening problem. But if you were going from hourly to daily, there's always 24 hours in a day. So that's very good fit for coarsening. And so group by kind of generalizes that. So it comes with some additional challenges, but it's I really like group by because it's a super flexible pattern. It applies in many, many places. And so Xarray provides this object to let you kind of reuse that pattern in many ways. So group by is kind of famous. There are two related ones, group by bins and resample. These are also group by operations. They're just tiny little specializations. The group by bins is for binning something like a floating point variable. So in oceanography, we would sometimes try to do bin by temperature and give it temperature bins and bin edges. So that's basically a group by. It's going to find all those bins and then do some aggregation in them. Resampling, that daily to monthly example that I gave you, that's also effectively a group by with non-standard bin sizes. And so the key concept really is usually group by gets presented as this idea called split, apply, combine. But really, I think there are actually 4 steps, which is the first you need to identify those groups that you're going to group by with. And so usually this little piece of the lecture just focuses on that first bit. And I kind of assume that you've already tried something like a group by before. And so the way this kind of analysis pattern works is you identify groups in your data. So that could be like construct, I like to think of ENSO phases as a good example. So El Nino phase, the neutral phase, and La Nina phase, right? And so somehow you need to create a time vector that identifies each time step as belonging to an El Nino year, neutral year, or La Nina year. Once you've identified those groups, then you can use that to split your data set into multiple data sets, one per group. So you could have a data set for all El Nino values, one for all neutral, and one for all La Nina values. And then you apply a function on that, maybe a mean or something like that, some kind of funny composite analysis that you want to do. And so for each of these groups, you get a result, and then you combine all those results back to get your answer. So the example here is a monthly climatology. So what I do is you call group by time to months, and we kind of dig into this some more, but the general group by object tells you that, hey, the output's going to have 12 groups, and these are the labels you're going to have, 1 through 12. You want to calculate monthly means, that's how you do it. You just call it the dot mean method. So just like rolling and coarsening. So something that was implicit here is this identifying groups business. So you've just told it time.month. On the back end, Xarray does something like this. So it creates this little vector that has values 1, 1, 1. That's saying, the first 3 values turned out are from January. The last 3 values are from December. So those has values 12, right? Maybe it might be easier if I plotted this, right? And so you can see, all Januaries have the value 1, then 2, and 3, 4, and then it comes back again, right? And so this is identify your groups. And so Xarray has done this for you. And then what it does is that split apply combine thing, right? So this is kind of implicit, and it's just mostly a convenient shortcut because it's so common. And so a similar pattern of identifying groups you could think of as binning. So here's group by bins. It is something similar. So you've given it the bin edges 20 to 35, 40, 45, 50. It figures out how to cut up your data into those bins, and then you can do some kind of aggregation. Similarly with resample, it's going to figure out that, okay, all of these belong to 2013 January, 2013 February, 2013 March, so on and so forth. With resampling, it keeps 2014 January separate from 2013 January, just by constructing the right label. And so you get 24 groups in the output instead of 12. And so the core concept there is you kind of have to create a variable that identifies the groups, and Xarray can do that for you. So that's why you would go to group by bins or resample, or even just a simple group by, like up here, 8 times a month. But sometimes it's not so easy, right? Whatever is built in does not work for you. And so then you kind of have to dive in a little bit, and I'll show you a few interesting things, but it's definitely, you can kind of do many complicated things depending on what your problem is. So here, I've just linked to a bunch of functions that are kind of useful. So NumPy digitize is useful for binning by multiple variables. Xarray actually uses pandas factorize for things like the time.month example, or pandas.cut when you call binning. They're basically all the same. They make slightly different choices in the name of performance, et cetera, et cetera. But fundamental concept is Xarray provides some built-in ways of detecting groups. And if that doesn't work for you, you kind of have to go look somewhere else. And I've linked to these functions. So you have like a funny group by problem that you're having trouble with, try some of these or ask a question at Zulip, and maybe one of us will help you out. There are some built-in things. So here's da.time, and I showed you time.month. So that's basically going through this .dt accessor. It's kind of complicated, but basically if you have a time variable, so it has to be this date time 64 thing, and you have to see its strings that look like a date. You can call this little .dt property, and it has a bunch of very helpful methods. On properties. So .day, for example, gives you day of the month. So you can see it goes from 1 through 30 and 31. So the end was December, so you have 31 days. Its word underlies this shortcut of just asking for time.day as a string. And you can do time.season. And this has, it's a good example. This is a very particular definition of seasons, right? It goes DJF, MAM, JJA, SON. It's very like Northern Hemisphere biased. And so there are a whole bunch of these. And so if you click this little link, we'll take you to our API documentation. And here's a list of properties that you could call. So things like seal, floor, I'll show you one of those. So also SDRF time. And then we looked at day, and you can see there's a whole bunch of these things. So days in month actually tends to be useful if you want to do some kind of weighting thing. And there's a whole bunch of properties so you could explore, including things like weekday and weekday name, if you need those. So yeah, I encourage you to click these things just so you know what's available. And then you can always go back and look for it if you feel like you have the reason. Okay, and so like I said, some Xarray has a bunch of built-in ones that could be useful and it works great. So here's season, but a few years ago, I was working in the Indian Ocean basin. Indian Ocean is funny because it has the monsoon season where the winds reverse, and they don't line up with these very clean 3-month seasons. So instead, what we want to do is December, January, February, March, April, May, June, July, August, September. So a 4-month season, and then October and November is a different season. So this has some physical meaning. And so that's why we want to do this. But you also kind of want to do seasonal climatologies, right? And so here now again, the challenge is identifying groups. And so here's a little how I did that for those custom seasons. So I started by first constructing the months, right? Because I'm using the month number to decide what season I'm in. So it's just this vector 1 through 12. I created a new empty NumPy array. So this is just saying, create an empty array. All it has are 4-letter empty strings, and it has the same shape as the month, right? So I'm going to have, for each time step in my original data, I'm going to have an associated season label. And then this is the fun bit. I'm using this function numpy isin, which is very cool. What it does is, it takes the month variable and says if it goes through every element, and then for each element, it checks whether that element is in this list of values that I like. So it's going to start with the first value, which is the month of January, and see if is 1 in 12 on 2. The answer is true, so you're going to see true there. So if I remove that 1, you would see now suddenly I have excluded January's for some reason, and you get false. And so that's what this little set of thing does, is it looks for membership. So it says, take the month number. Are you in 12 on 2? If so, assign the value DJF. Similarly for March, April, May, 6, 7, 8, 9 for that 4-month season, and then 10, 11 for October, November. And then I just convert that in a little, data array. What do I do? Yeah. Kind of just went out of order there. And so here, what I've done is identified my groups using a little custom criteria. Here I use custom seasons, but you could do whatever you want. The kind of core concept there is I wanted to create a seasonal climatology. The built-in season identification didn't work for my problem. So then the problem then is really just the problem of identifying the groups. It's not about calculating the mean later on. It's just to do this. And so once you have this, you could do da.group by season, and you can see I'm going to come out with 4 groups, and you can see I have my funny labels. I call the mean. This should work, and this is kind of an approximate climatology. And we can view it too. And you can see that out of order. This is a common problem. It tends to do alphabetical, which is annoying. So usually I just call the index to make it the order I want. There you go. So December, January, February, March, April, May, June to September, and then October, November. Not so meaningful over North America, but useful somewhere else. Was that clear? Are there any questions? That was kind of a lot in a short amount of time. So I guess we're running out of time. There's only 5 more minutes. And so I'll just kind of do an overview. The point of this lecture is really to show you things that you can refer back to later. You don't have to fully get it right now. And so on the same idea of identifying groups, so again, here's our time vector. You'll note that this is 6 hourly frequency, right? So 6, 12, so on and so forth. You can float that to a daily frequency. So this would be something like doing a resample back to daily frequency. So you could group by this little variable called the mean, and it resampled. Again, on the topic of being more custom, there's an strf time method that's pretty complicated. You give it these complicated strings and it will format the date as a string for you. It's so complicated, it has its own website, strftime.org. And so you plug this code, you'll get that example output. And as you can see, there's a whole list that you can choose, but in particular, it's useful for group by columns sometimes. Similar to rolling and coarsening, group by also has reduce. So here you can apply your own custom numpy function. So here I did monthly climatology, so 1 to 12. It's exactly the same as calling that mean, just that you could do whatever you want. Group by does not provide a construct because remember it works in label space, not index space, so they're not the groups need not have the same length. So instead, one way to do this is to loop over. So you can do label comma group, like this. And you can see that the label has taken values 1, 2, 3, 4, 5, 6, 7 through 12, because that's what the group labels were timed out month. And group ends up being an Xarray data array that has, in this case, all December values, because it's from the last iteration of the loop. So if you look at this time, it has 2013, 12, and it also has 2014, 12. So you can loop through. Usually you need to loop when I'm plotting something. So here's the histogram of temperatures for December, because that was stored in group. In many cases, it's slightly nicer, up to you, but it's slightly nicer if you use the map method, which is exactly like a for loop. But again, now, as I mentioned earlier, map, you receive a data, an Xarray object, and you return an Xarray object. So this particular example illustrates calculating the interquartile range. So I called the quantile q equals 0.75 along a dimension that is unspecified, but it's an argument for that function. And then I mapped that for this group by thing, and I gave it the time dimension. And you'll see it comes out now with the IQR for each month at each lat long. Oh, anyway, so that was it. So the summary is there's this index space, label space, and a bunch of high-level patterns. The point of this book was to show you cool ways to use them, with the idea being that you should be able to find these patterns in whatever you're doing. And there's some advantage to just reusing the code that exists. With that, I'll take questions. I'd be very happy for any feedback if you have on this stuff. Thanks.
Great job, Deepak. Thank you so much.
Yeah.
And thanks everyone in the chat for expressing your gratitude and asking questions throughout the way. If you have any more questions, please ask them now, or we'll end the call in about 2 minutes. Okay, we have one question from Ken.
So Ken asks, when I use resample on data set, it converts my int data to float. Is that a way to keep data type to int? Int to float. I'm really surprised, I guess. Oh no, are you calling mean? You are calling mean. Okay, so a follow-up question for Ken is, are you calling mean on your int data, or are you calling sum? Mean will promote to float because you have to do a division. Okay. So Danica asks, you recommended earlier using Coarsening or construct, but group by seems more flexible. Are there stronger benefits to using Coarsening? There is a very big, today there is a huge performance benefit to using Coarsening, just because it works as fixed size. You just reshape the array and you call like construct, and then you call mean, and that's super efficient. It's something array libraries do very well. Group by today in Xarray is implemented as a kind of for loopy thing, and so it's going to be slower. Yeah, it's going to be slower. And so there's, and with the Dask array, using Coarsening, if you can, is also recommended, because again, it's just going to work a lot better than doing the group by thing. So there are some like performance considerations, even though they're basically the same idea. Yes, exactly. Coarsening is computationally efficient. Dapeng Li asked, does Coarsening consider the cell areas? No, Coarsening is very stupid. Actually, most of Xarray is very stupid that way. It has no knowledge of the underlying grid, basically. It has no knowledge of the underlying grid, so it does not attempt to do any weighting based on cell areas. Usually for that kind of thing, if you really care about the grid, look to XGCM, which tries to help with that problem. It adds a general understanding of staggered grids to Xarray and makes it very convenient to do grid-aware operations. So Xarray is basically no knowledge of the grid, so it cannot do anything about it. And so another follow-up question for Ken is, you say you're resampling the time bins, but are you calling the mean, or are you calling something else? That's going to decide whether it promotes to float. Adriana asks, would you recommend just creating new labels to do multiple group bys? Do you mean group by multiple variables? Yeah, okay. Yes, pretty close to getting it implemented in Xarray, but yes, you could. Yeah, so if you wanted to, like, you could group by lat something. It's kind of annoying, I guess. I think maybe I'll try and write a blog post on it. So I try to make it up right now. It's kind of with that. Yeah, I think I'll leave it at that. Xarray's group by thing is going to get a lot better soonish in the next month or so. So hopefully that'll be good enough. It's just really painful at the moment. So trying to figure out how to do it is painful. The one thing I could point you out to is this very awesome package called Xhistogram. It's, again, histogramming is also basically a group by operation, but it's very specific. It does counts number of observations, but you can build up from there to do anything you want. So if you look through these examples, you'll find, for example, grouping over multiple variables. Yeah, so here, oceanographer, so here's an example I tend to understand. Here we have T and S. And so he's calling histogram with the salinity and the temperature, and he's giving salinity bins and temperature bins, and this ends up being the number of observations. So you can kind of generalize this to things like the sum or a mean, grouping by multiple variables. Here he's grouped by salinity and temperature. So if you want to do it, Xhistogram is a good way to do it. If not, just wait a little bit. To it. Are there any tips or tricks to mixing group by and coursing from Seth? For example, a multi-year rolling 30-day average. I don't know what that means. Yeah, I don't know what that means. A rolling 30-day average, but also averaged across the years. Yeah, so I think that's where construct is really useful. Yes, let's go back up. So I think this is the kind of thing where construct is useful. Like, it's hard to, like, the analysis problems are fairly complicated. And so Xarray tries to just provide the most common patterns, and then we try to provide more general things like coursing so that you can implement your own. I think what I would do is try this and then go rolling on the month dimension, which for you would have been day dimension, I think. Right, so you could go slide along this dimension. See, so if I did month equals 4, so that's not what you wanted. You wanted both time, month and year. But that didn't do what I thought it would. Yeah, I think you might have to build this up yourself, right? Like, so you'll have to do, this is a rolling object. It looks like that. And then accumulate the sum. Oh, you could construct. Right, so yeah, so this is kind of mind bending. So I took Coarsening, I broke it up into year, months, and then we wanted the rolling long months, and I constructed that, and now we can mean window and the year, and that gives you a 1D output. So I think this is what you want to write, set something like this. Yeah. So yeah, that was a cool example actually. So this shows you the power of constructing, which lets you compose many little pieces together, right? So you had a 1D thing, I broke it into 2D thing, year by month, sets example, day. And then I did rolling across the month dimension, and my first mean attempt didn't really work. So I broke the problem down, I called construct again, and then that let me do this window year business. And I think that looks right. So good reason to use construct when you have these complicated problems. Any more questions? Great, thanks, Bert. Insightful as what I was hoping for.
Thank you so much. Okay, thank
Yeah, you're
you,
welcome.
everyone. Thank you, Deepak. And we'll see you next time. Bye.
Bye-bye. Thanks.